Okay, hi everyone. In this session, we'll solve one more problem related to moment, related to non-coplanar force system. The problem is about determine the magnitude, direction, and position of the resultant force with reference to the point O for the coplanar non-concurrent force system shown in the figure. Take size of each square as 200 mm into 200 mm. I have a particular square, and in that square I have a number of again I have a number of squares. Each square having size of 200 mm into 200 mm. I have three forces: 200 Newton force first, which is purely vertically downward force. Again one more 200 Newton force acting at a point O, and one more force I have 500 Newton acting at this particular point. And you can see here some dotted lines. These dotted lines are given only to calculate the inclination of these 500 Newton force and 200 Newton force, either with respect to x-axis and y-axis. Here in this particular problem, along with the forces, one moment is there, so called 200 Newton meter, and it is a anti-clockwise, it is a clockwise moment. And during the solution of problem, no need to worry about this particular 200 Newton meter moment. We need to add or deduct this particular moment with respect to while developing the moment equation about point O. Okay, if it is a clockwise, just add; if it is anti-clockwise, just deduct. Okay, coming to the solution part of the problem, first once after giving the problem, we need to find the included angles. This angle I will give it as a theta 1 with respect to x-axis, and this angle I will give as a theta 2 with respect to horizontal axis. This is my horizontal theta 2, this is my horizontal theta 1. Theta 1 is nothing but we will get a form a right angle triangle here. Small square, this length I know it's a 200 mm. Again this will be 200 mm. Theta 1 is tan inverse 200 by 200. It works out to be 45 degree. Similarly, it is 200 mm. This will be vertical part of theta 2 side. Overall, it form a rectangle triangle. In this rectangle triangle, this adjacent side will be adjacent to theta 2 will be 200. Opposite side will be 200 plus 200, 400. So theta 2 is opposite tan inverse opposite by adjacent. So theta 2 is tan inverse 400 by 200. It works out to be 63.43 degree. Once after that, resolve each forces from the point where that particular force originates. From this particular point, x component will be 500 cos 63.43. This 500 Newton force going away, so 500 cos 63.43 is should also go away from point of consideration. So it acts positive x direction. 500 sin 63.43 acting positive negative y direction. So coming to this particular force, 200 cos 45 acting positive x direction, because 200 Newton force is diverging towards point O. 200 cos 45 is also diverging towards point O, and I have another force 200 sin 45 which is acting upward direction, and another force of 200 Newton force here acting vertically downward direction. While the first step I need to develop f of x, f of y equations, I need to forget about 200 Newton moment while developing this equation. Now first f of x is add all horizontal force 500 cos 63.43, 500 cos 63.43 plus 200 positive direction 200 cos 45, and these are the only two positive direction, only two horizontal forces, and answer works out to be 365.07 Newton. And similarly develop f of y equation. I have minus 500 sin 63.43 and one more force plus acting vertically upward direction, so it is a plus 200 sin 45 and minus 200 Newton. Answer works out to be minus 505.77 Newton. And similarly calculate r and theta, and those works out to be 623.76 Newton, and theta equal to tan inverse summation f of y divided by summation f of x. The answer works out to be 54.18 Newton. Now once after that, I need to find moment about O. I need to develop equation of moment about O. It is nothing but moment about O is nothing but I will consider one by one force. First I will consider 500 cos 63.43. If I take this force, it's a pure vertical force. The if force is horizontal, I need to consider perpendicular vertical difference between O point and this point is 0. So 500 cos 63.43 into 0. No need to write. Entire answer works out to be 0. The next force 500 sin 63.43 it's a pure vertical force, I need to consider perpendicular horizontal difference between O and this. It will be 200 plus 200 plus 200 plus 200, 800. 500 sin 63.43 into 800, and entire answer with respect to O, it is going to rotate in clockwise direction. So it is a plus 500 sin 63.43 into 800. And next force we have, anyway I have to resolve force at O. It is not going to contribute because that force starts from the point of consideration, that is O. So these forces, moment of these two forces, that is 200 cos 45 and 200 sin 45, is about a point O is 0. And next coming to this 200 Newton vertical force. When force is vertical, I need a perpendicular horizontal difference between 200 Newton force and moment center O. In fact, perpendicular vertical difference between 200 Newton and this moment center is 0. So a perpendicular horizontal difference between 200 Newton and O is 0. So it will be 0. So only contribution is 500 sin 63.43 only. And along with that, we have a clockwise moment of 200 Newton meter. Just if it is a clockwise, just add. If it is anti-clockwise, just deduct in moment equation. Since it is a clockwise, I need to add. But you can see here 10 to the power 3. I have multiplied with 200 plus 200 multiplied by 10 to the power 3, because all unit of force is nothing but Newton, but unit of moment is also Newton. Along with that, unit of distance is nothing but in mm, but here it is given is in meter. So I need Newton mm, because force is Newton, distance is mm. Okay, so here 500 sin 63.43 is in Newton, but 800 is in mm. So this answer 200 into 10 to the power 3, this moment should also be in Newton mm. So in given problem, it is mentioned in Newton meter, so I will convert to Newton mm by multiplying meter to mm. Conversion is 10 to the power plus 3. I need to multiply by 10 to the power plus 3, and entire answer works out to be 557755 Newton millimeter. From that I can calculate the x intercept, y intercept using those formulas. Okay, thank you.